Hello, scholars. Welcome to Unit 6. What are we talking about this unit? We're going to be talking about astronomy. It's one of science's oldest fields of study. All right. Last semester we did all physics. After astronomy, we're going to move into chemistry. Astronomy is kind of the bridge unit. It takes a lot of the ideas of physics and also can introduce some of the ideas we'll talk about in chemistry. So let's get started. What is astronomy? The study of celestial objects. What do we mean? The objects in the heavens, in the sky. The sun, the moon, the stars, the planets, comets, galaxies, things like that. It's the oldest of the sciences. All right? As a 12, 13-year-old boy, if you lived 3,000 years ago, you would know the sky. You would be the one up late at night watching the flocks, guarding the camp. And so you would know when the moon rose, or how the stars turned in the sky, and which ones were up in different seasons. Because this movement of objects through the sky allows us to keep time. Okay? What's the biggest thing in the sky? The sun, of course. Right? As the sun rises in the east and sets in the west, it gives us direction, but then it goes around and it rises again. That 24 hours that it takes for the Earth to rotate on its axis, for the sun to rise, set, and rise again, that's how we define a day. It's how we mark time. This is caused by the rotation of the Earth spinning on its axis. Does the sun move? Well, kind of, sort of, but it's not actually moving across our sky. We're spinning, and as we turn away from the sun, nightfall happens. When we turn into the sun, sunrise happens. Same thing happens with the moon. How do we mark our months? In the old days, months used to be 28 days. Why? Because that's the time it takes for the moon to do a full cycle of its phases, from full moon to full moon. That has to do with the moon's revolution around the Earth. So the moon goes around the Earth, and as it revolves, that takes 28 days. That's the average length of a month. Now, with the modern calendar, we've added a few days here and there to make up for the fact, so to align with our year. Okay. Next thing, we mark our years and our seasons by the revolution going around in our orbit around the sun. Okay. In the summer, okay, the northern hemisphere is tilted towards the sun. In the winter, we're tilted away from the sun. And this allows us to understand the seasons and predict when certain types of weather patterns are coming. So we can plant crops and grow food and follow the herds. And so this understanding of astronomy and how objects move in the sky allows us the power to track time and predict events. So the big idea here, okay, you have rotation, the Earth spinning round and round and round on its axis. Okay, you have revolution, which is going around the sun on the orbit, in its orbit. Or you could have the moon going around the Earth. That's also in orbit. Okay, so rotation is responsible for day and night. Revolution is responsible for our yearly cycle. And as you can see, the Earth isn't perfectly up and down. Okay, it's tilted slightly on its axis. So when we're in the northern hemisphere, tilted towards the sun, it's summer. Over here, we'd be tilted away from the sun, and it's winter, like it is right now. All right, make sure you fill out your worksheet. We'll see you in class.